Now we are going on and we are looking at Hess law. Let's see what it is and what it helps us to find. So we have talked about a calorimeter. Calorimeter is just, remember, the unit that we'll be using to measure the delta H of a reaction. So we'll be having a reaction, we make it happen, and we'll be measuring the heat transferred or the heat that is absorbed or released in that reaction, and it can easily give us. Now, we may have a reaction which does not proceed in a laboratory setting, okay, in our lab. So for us to be able to measure the delta H for those situations or whatever other situations you may meet, it would be impossible. We may have some reactions that are hard to measure directly. But what we can do is you may find out that we may be able to measure the delta H of related reactions. So you may have some reactions that are related to the one you want, and we'll be able to measure their delta H, which is their heat, the heat that is transferred in the reaction. Either it is in or out, we don't care. But we may be able to measure their delta H. These are the related reactions. If we are able to measure delta H of related reactions, we can then use Hess law to change the ones that we have that are related to the one we want. That is what we're going to be doing with Hess law. So let's see what it says. It says that the total enthalpy change of a chemical reaction is the same regardless of whether the reaction occurs in one step or multiple steps. So what we are looking at, the keyword here is the total enthalpy change. At the end of the day, when we look at the total enthalpy change, it doesn't matter if you got the enthalpy directly or you had to do several steps to get to the final that you need. It is going to be the same. In other words, we can say that enthalpy, this key, is a state function. So what we want is enthalpy change, the heat that is transferred. And this is a state function. It is independent of the path that you have taken to reach the final state, as long as you are coming from the reactants that we had and getting the products that we want. Then we don't care how you move, how you come from the reactants to products. Either you do it in one step or you do it in 3 steps, as long as you come from the reactants to products. When you sum up those enthalpies of the same reactants making the same products, we don't care if you did it in 1 step or 3 steps, the enthalpy is going to be the same. Let's do an example. So here's an example. We want to find this one with a question mark. That's the one we want to find, delta H3, right? We want to find this delta H3. So we don't know what it is, but we know the delta H's of similar things. This is the reaction between nitrogen and oxygen. What we want to make is right here. We want to make nitrogen dioxide from nitrogen and oxygen. But if we combine nitrogen and oxygen, look at what it's giving us. It's giving us nitrogen monoxide. Then the other reaction is now nitrogen monoxide meeting oxygen to give us nitrogen dioxide. So there is no reaction that we have that comes directly from nitrogen, combining nitrogen and oxygen to give us this guy. We don't have, but we have it in 2 steps. First, we'll get this mediator, this intermediate, and this intermediate is going to meet oxygen and then form the final product. So either way, what I know is, since I want N2 and O2 to whatever, I can be able to combine. So this is what you do with Hess law. What you do with Hess law is your focus is going to be on the reaction you want. What is the reaction you want? I want this reaction, nitrogen meeting oxygen, to give me this guy. So what I'm going to do is I'm going to start taking my species one at a time. I'll start with nitrogen. I'm going to go to the reactions and look for nitrogen. So what happens is, if nitrogen is going to be there twice, you skip it for now. You come back later. So I'm going to look for nitrogen in these 2 reactions, number 1 and number 2. How many times is nitrogen appearing? I start with, remember, I'm building from the one I want. I'm looking at the reaction that I don't have enthalpy for. And I'm taking the things that are in there and looking for them in the reactions that I know enthalpy for. So I'm starting with nitrogen, okay? Do I have it? Yes, I have it. So what I'm going to do is I look for nitrogen. Where is it? It's at the reactants side. And how many moles is it? 1 mole. Then I go to this number 1. Where is the nitrogen? At the reactants side. And how many moles? 1 mole. So I'm going to take reaction number 1 as it is, because I have exactly what I want. So I'll now write N2 gas plus O2 gas, giving me 2NO. This is my equation number 1, where I have my delta. I can call this equation number 1. Okay, we will write it as, I can say equation 1 is now N2 gas. I'll show you why you have to rewrite doing this, plus O2 gas to give us 2NO gas. And I know that my delta H1 is plus 180.5 kilojoules. I didn't have to change anything. Now let's look for the second one. What do I have? 2O2, right? 2O2. Okay, so I have O2. Do I have O2 in the other ones? So I know that I've already taken number 1. So I'm looking at number 2. Do I have O2? Yes. So what I'm going to do is I go and check in 1. Did I have O2? Yes, I had it. How many moles? 1. So how many moles do I want in the final one? I want 2. So how many should I bring in number 2 now? I already have 1 already. So how many should number 2 bring? Number 2 should bring 1 more mole. So that means I'll just bring number 2 as it is. The oxygen should be at the reactant side, and it should be 1 more mole, so that I'll add the top and the bottom. So I'm going to bring it. Oh, lucky me. Nothing has to be changed again in the second one. Plus, I say O2 gas to then give me 2NO2 gas, and my delta H2 is equal to plus 66.4 kilojoules. Now, then I would then use these two to make this will be my equation 2, okay? This will be my equation 2. Then now I can make my equation number 3. How do I make my equation number 3? I'm just going to put all the reactants, then all the products together. So what are my reactants? I had N2 gas plus O2 gas plus 2NO gas plus O2 gas again. Then what is it forming? On the product side, what do I have? 2NO gas plus 2NO2 gas. Okay? Then what would I have? What would I then have? I'll look for spectator ions. If there's a spectator particles, if there's anything that is appearing on both, here we go. NO is there on both sides, so I'm going to cancel it. And what will I then have in the final thing? I'll have it as N2 gas plus O2. How many do I add this O2 and another? So it'll be plus 2O2 gas to give me 2NO2 gas. Okay? I've combined these two. Then what do I know about my delta H? My delta H3 would therefore be equal to delta H1 plus delta H2, because I just combined them, which would be 180, okay, you can say positive 180.5 kilojoules plus 66.4 kilojoules. Okay, we can first put it as just 180 plus 66.4, and that's just what we'll do. We'll now say 180 plus 66.4, 180.5, I'm sorry, 180.5 plus 66.4, we'll get 246.9. So it is equal to 246.9 kilojoules. And here we have used Hess law. We have found our delta H and we have found our overreaction. So you can now write, if you want, N2 gas plus 2O2 gas, 2O2 gas gives me 2NO2 gas. And I can say the delta H reaction of this, you can just say delta H if you want, will be equal to 2 positive 246.9 kilojoules. And this is the end. You are done. Okay? Bye for now. See you in the next one.